All right. Well, welcome to today's teaching with Anakwa Christopher Ejike, your chemistry teacher. Um, let's take a look at this particular picture. Uh, we are familiar with seeing an object, metallic object outside. When iron is being exposed to the atmosphere for a long time, or begin to see or experience something like this. And the usual thing is for us to say that the iron is rusting. Actually, iron is actually rusting. It is rusted. Um, but in a real sense, something is happening because that the iron is being exposed to the atmosphere. We know that in the atmosphere we have water. So a droplet, water droplet, day in, day out, water will drop on the iron. What is happening to this iron is what we call that the iron is oxidized. Oxidation is taking place in this iron. From the normal iron it is to the iron 2. And the water molecule, the oxygen that is affecting the whole thing, the water molecule there, the oxygen is being reduced. So reduction is also taking place simultaneously. As the iron is being oxidized, the oxygen is being reduced, and it occurs simultaneously. This is what we lead us to what we have for today called oxidation reduction reaction. Our topic for today is oxidation reduction reaction. All right. It's expected by the end of this particular class, you learn some things. The aim of having this class is for you to be able to define oxidation in terms of, number one, exchange of oxygen and hydrogen. And number two is for you to define oxidation in terms of electron transfer and also to define oxidation reduction reaction in terms of change or changes in oxidation states. You have to define it by the end of this particular lesson to define oxidation reduction reaction in terms of these particular areas. If any of them is being referenced to you, you will define it based on that. All right. Oxidation reduction reaction actually is a short form of saying redox reactions. Redox. Redox is reduction oxidation reaction. And it can be defined in several ways. As our objective says it, carries it, that we will be looking at it in several ways. Now, I said before introducing the topic that oxidation and reduction occur simultaneously. That is one thing we need to know. In a given equation or reaction, simultaneously, as oxidation is occurring, reduction is also occurring. Because two of them are needed for a reaction to complete. So, if you want to define oxidation reaction in terms of oxygen, you say that oxidation is an addition of oxygen. It's the process of adding oxygen to a substance, or you say it's to gain oxygen, while reduction is the removal or to lose oxygen. Oxidation is to gain, while reduction is to lose in terms of oxygen. Now, if you want to define oxidation reaction or reduction reaction in terms of hydrogen, it is the opposite of exchange of oxygen. Now, oxidation has to do with removal of what? Hydrogen, while reduction is an addition. Addition of hydrogen is to gain hydrogen, while oxidation is to lose hydrogen. The same way is in definition of electron transfer. When it has to do with electron transfer, oxidation is transfer of electron, is to lose electron. When electron is being given out, it's being transferred, lose electron, a metal or a substance lose an electron, we call it oxidation. But when electron is being gained, we call it reduction. So an addition of an electron is also reduction in terms of electron transfer. And finally, when you think of oxidation reaction and the reduction reaction in terms of oxidation number, oxidation increases the oxidation number of a particular substance, while reduction decreases it. We will be looking at it one after the other. We will be defining oxidation reduction reaction in terms of oxygen, exchange of oxygen and hydrogen. If you are to define oxidation reaction in terms of oxygen or hydrogen, you said that oxidation is the addition of oxygen, or you said that is a removal of hydrogen from a substance. Addition of oxygen to a substance or removal of hydrogen from a substance. While reduction is the addition of hydrogen, still remember the picture I showed you initially, and the removal of oxygen from a substance. It's opposite of each other, but they occur continuously. Now, for such a reaction to take place, we have what we call oxidizing agent, and a reducing agent. Oxidizing agent now is the substance, is the agent that does the oxidation work. Is the substance that adds that oxygen or removes hydrogen from a substance. Is always found in the reactant side. The same thing to reducing agent is the substance that now remove oxygen and add hydrogen to a substance. Is also found in the reactant. So reducing agent and oxidizing agent occur at the reactant side of a given equation, so that at the end of the reaction, it will get that particular substance reduced and oxidized, where thereby we have oxidation and reduction reaction. We'll take some examples of oxidation and reduction reaction in terms of oxygen and hydrogen. One is extraction of iron from its ore. Iron ore, when iron is being extracted from its ore, what actually takes place? Oxidation reaction and the reduction reaction also take place there. In the fullness of the extraction, the ore is being reduced to a metallic ion when iron ore reacts with carbon 2 oxide. So with the given equation, as you can see, iron ore is being reduced. That is iron 3 is being reduced to a metal ion. We call it reduction because oxygen is being removed from that ore. And carbon 2 oxide, as you can see, is oxygen is being added to that carbon 2 oxide to become carbon 4 oxide. We call it oxidation. So in that above example, we can see that iron 2 oxide is acting as an oxidizing agent. Why? Because it has oxygen on it. It has the ability to add oxygen to another one, while the carbon 2 oxide is the reducing agent because it's the one that will collect or receive the oxygen from another one. So another example we can give is in terms of hydrogen. I said that hydrogen, addition of hydrogen is what we call reduction, but removal is what we call oxidation. So here, hydrogen sulfide, as you can see, at the reactant product side, hydrogen is being removed from sulfur. It becomes oxidation. While chlorine in the reactant side, on the product side, hydrogen is being added to it. We call it what? Reduction, because hydrogen is being added. So at the reactant side again, we still have reducing agent and oxidizing agent. But that reducing agent will be oxidized at the product side, and the oxidizing agent will get reduced at the product side. That is how it works. When you define oxidation reduction reactions in terms of electron transfer, is also a different side of it. Still remember that oxidation, to define oxidation reaction, oxidation and reduction reaction in terms of oxygen and hydrogen is the old way. They are the old way of defining oxidation reduction reaction. But the most recent way of defining oxidation and reduction reaction is in terms of electron transfer, or either in terms of oxidation number. So in terms of electron transfer, we say that oxidation is a transfer of electron. When an atom loses an electron, we call it oxidation. While when a substance or when an atom gains an electron or gains electrons, we call it reduction. Still remember, oxidation is loss of electron, while reduction is gain of electron. Thereby, definitely, at the end of losing an electron, the positive character will increase. That means the oxidation number will increase. While the reduction, definitely the oxidation number or the positive character will decrease. The acronym we can use to remember the oxidation in terms of electron transfer is OE. While the acronym we can use to remember reduction in terms of electron transfer is RIG. Oxidation is loss of electrons, while reduction is gain of electrons. That is RIG. OE. Oxidation is loss of electrons. Now, another acronym we can use is LEOJA. LEO means loss of electrons is oxidation. YJA means gain of electrons is reduction. So by this way, we can use to remember what oxidation and reduction is. Let's take some examples again on this. In the above example, we can see copper 2 ion and the magnesium metal reacting to form copper metal and magnesium ion. What actually happened? What happened is this: that copper 2 ion receives 2 electrons from magnesium atom in order to become copper metal and magnesium ion. So in the above reaction, as we can see, oxidation occurs between magnesium to magnesium ion, while reduction occurs between copper 2 ion to copper metal. We can see that the positive character of copper is being reduced, while the positive character of magnesium is also increased instead of reducing. So in the above reaction, magnesium acts as a reducing agent, while copper 2 ion acts as a oxidizing agent. Let's take some examples also. Question 2007, number 30, wire question. Question says, which species undergoes reduction? And the reaction represented by the equation below. In this kind of question, either the one that undergo reduction or the one that undergo oxidation, it's expected that you need to analyze the question following from the reactant to the product. Compare each element or substance in the reactant and the product to know the one that is reduced if you ask of reduction. Now here we can see that sulfur appears in the reactant side and also appear in the product side. Reactant side, it appears as -2, but at the product side is positive, is 0, which is from -2 to 0, the oxidation number. That is increasing. Iron is ion 3 at the product side, at the reactant side, but at the product side is ion 2. That is reduction. Chlorine is -3, from -3 to -2. From ion 3, chlorine in that ion 3 is -3, and in the product side is ion 2. So it's actually ion 3 is what is reduced from ion 3 to ion 2. So the answer to this particular question is ion 3 is what is being reduced. Okay, if you have been given this particular question, reaction of sodium and chlorine, we can see that chlorine loses 2 electrons. Chlorine gains 2 electrons to become chlorine ion, while sodium loses 2 electrons to become sodium ion. It loses 2 electrons, which is loss of electron is oxidation. So oxidation occurs between sodium atom to sodium ion, while reduction occurs between sodium chlorine molecule to chlorine ion. That is reduction. Reaction also between sodium and oxygen. We can also show that oxidation occurs between sodium atom to sodium ion and oxygen atom or molecule to oxygen ion is gain. That one is a reduction, but gain 2 electrons. Let's talk about when we consider oxidation reduction reaction in terms of change in oxidation number. When combustion takes place in methane, when methane burns in air, we have an equation like this. And here we can see that the oxidation number of carbon changes from -1 to -4 to +4. That is increment. Oxidation number increases. We call it oxidation. In terms of oxidation reduction reaction, when defining it in terms of change in oxidation, oxidation increases the oxidation number, while reduction decreases the oxidation number. So here we can see that carbon moves from -4 to +4. It's oxidation. Oxygen moves from zero oxidation number to -2. That is reduction. From 0 is greater than -2. It's reduction. So reduction takes place at oxygen from 0 to -2. But at the combustion of carbon, we can see that oxidation occurs from carbon 0 oxidation number of carbon to +4 in the product side, and the reduction is from 0 to -2 in the oxygen. So oxygen is where the reduction reaction takes place, and the oxidation takes place at carbon atoms. All right, so let's still take more examples or two or cap it up. A reaction between the manganese 4 and the hydrogen chloride. You can see the oxidation number of manganese moves from +4 to +2, which is reduction. The oxidation number decreases, while that of the oxygen moves from, it remains -2, so it's unchanged. For chlorine is from -1 to 0. It increases. -1 is smaller than 0. So oxidation occurs at the chlorine molecule, between the chlorine at the reactant side and chlorine at the product side. Then finally, when we consider the formula, chromium moves from +6 to +3, and the sulfur from +4 to +6. So +4 to +6 is oxidation, increase in oxidation number, while that of the chromium is where the reduction takes place. In fact, one of the simplest ways to determine oxidation reaction in a given equation is the use of oxidation number. So far, we have said that oxidation reduction reaction can be defined in terms of exchange of oxygen and hydrogen, but the most recent way to define it is when you define it either in terms of electron transfer or in terms of changes in oxidation number. But still remember that one of the reactants must definitely be an oxidizing agent, and another will be reducing agent. Take this question as your assignment. You have to define oxidation number in terms of electron transfer. It's why question 1995, number 5. Then the question now, copper reacting with a silver ion to give copper 2 ion and a silver metal. Question says, which species is reduced? Look at that question very, very well, and find out the one that is reduced with following what I've taught you. And second question says, consider the following equation and look at the oxidation number. How does the oxidation number of chromium changes from the reactant side to the product side? And finally, question says, which one is oxidized? Which is oxidized in the reaction? Represented below is why question 2001, number 3 question. As you write it, you submit it to you can use my WhatsApp number or email address. WhatsApp is 080-655-73229, or send it to christo116@gmail.com. Or you can also call for other discussion on it. Further studies, you can consult your Understanding Chemistry by Godwin Odokuku, New School Chemistry by Ababio, and online materials are available for you.